All right, we're going over 4.1 to 4.4 review. This is part 3. We're picking up on question 15. All right, it says to find the coordinates of the point of intersection of a 210-degree angle and the unit circle. That just means an angle whose terminal side intersects the unit circle. So we're looking for at a 210-degree angle, what point is that on the unit circle? So I'm going to draw my XY axis and the terminal side of my 210 degrees. Okay, this would be 180, and you go 30 more. So right here is your 210-degree angle. So where would this intersect the unit circle? This is what they're literally asking. I'll draw you a picture so you can see it. If this is the unit circle, it's not quite centered. There we go. What is this point on the unit circle? So if that radius is 1. So you need to know your reference angle. If this is 210 degrees, like I said, that's going to be 30 degrees past 180. So you have a 30-degree reference angle. When you have a 30-degree reference angle, your cosine and sine, so your x and y, are square root of 3 over 2, 1/2. Now you need to think about what quadrant you're in. You're in quadrant 3. X and y are both negative. So the coordinates of the point of intersection, this point right here, are negative square root of 3 over 2, negative 1/2. 16 is finding the quadrant that the angle is in, given that cotangent is less than 0. That means negative. So in which two quadrants, draw a quick picture for you, in which two quadrants is cotangent negative? So think about our mnemonic. All students take calculus. Remember, that stands for all trig functions are positive, sine is positive, tangent is positive, cosine is positive. Okay? The reciprocals are the same. So that means the cosecant is positive here, cotangent is positive here, and secant is positive here. The rest in these three, if they're not listed, are negative. So cotangent is negative in 2 and 4, because right here they tell us it's positive. So these two are out. Now we're also told cosine is greater than 0. So cosine is positive. Cosine is not positive here. Cosine is positive here. So quadrant 4 is where they overlap. (17) tells us to let theta be an acute angle. That right there tells you what quadrant you're in. Acute means less than 90. That means you have to be in quadrant 1. So in quadrant 1, find the indicated trig function if secant is square root of 41 over 5. So I'm going to draw my quadrant 1. And my triangle inside of it. Secant, remember, is the reciprocal of cosine, and you should know, hopefully by now, the ratio for cosine is x over r. So secant must be r over x. So that means this is my r and x. So x is 5, r is square root of 41. And then I can use Pythagorean theorem to find my y. Don't rush again. Make sure you plug in your numbers to the correct spot in Pythagorean theorem. When you square a square root, cancels. So you're left with 41. And then you have to subtract 25 over. When you do that, you're left with 16. Now when you take the square root, again, I've told you over and over, don't forget your plus and minus when taking square roots. The quadrant is going to tell you if you're using the positive or negative. Where in quadrant 1, everything is positive, the y, and the x. So we want the positive square root of 16, which is a positive 4. So y will be 4. And now they're asking for tangent, and you should know by now again, tangent is y over x. So 4 over 5. Okay. 18, evaluate the expression without the aid of a calculator. You need to understand when you see this -1 exponent, -1 exponent on a trig function, that's inverse. Okay, so this right here reads inverse sine of -1. And what that literally means, if you think back to when we do our trig functions, we take an inverse when we're looking for an angle. So this question is asking, I should put the at what angle is sine's value -1? That's the question. So when you see this on your test, that's what they're asking. At what angle is whatever trig function's value this number? Okay, so think about your unit circle, because you can't just type this into a calculator. This is on the no calculator section. The 1 for your sine, because if you remember back, hopefully you remember, this is what we're looking for. Sine is your y value of your x and y coordinate. So where you have a 1 is going to be here, 1, 0, 0, 1, -1, 0, or 0, -1. We're looking for -1 for the y. So for my y value to be -1, here you go. So what angle is that? So here's the angle we're looking for. It doesn't specify if you should give it in radians or degrees, so I would take either. So you could tell me 270 degrees or 3 pi halves. I'd take either answer. On 19, you're given tangent of theta is -12 over 5, and that sine of theta is less than 0. That means negative. So we need, and this is also negative. So we need to figure out which quadrant both tangent and sine are negative. So just think back to our all students take calculus. You're going to use this over and over and over. Hopefully it'll just be second nature to you eventually. So tangent is negative in 2 and 4. Sine is negative. Oh, S, that's sine. That means it's positive here, so I can't use that. So quadrant 4. So I'm going to draw my picture in quadrant 4. And tangent is y over x. So my y is 12, my x is 5. One of them has to be negative, and that's going to be the y, because we're in quadrant 4. Okay, you can use Pythagorean theorem to find your r. And hopefully, some of you at least, recognize this as a Pythagorean triple. This is a 5, 12, 13. Okay, so if you know that, you don't have to work out Pythagorean theorem. R is 13. If you don't have that memorized, go ahead and do 5 squared plus 12 squared equals r squared and work it out, and you get 13. Okay, and then cosine is x over r. So x over r. Both of those are positive, and cosine should be positive in quadrant 4. Let theta be an acute angle. Again, that tells us we're in quadrant 1. Use the given function value and trig identities to find the indicated trig function. If cosine of theta is 60 over 61, find secant of theta. Your trig IDs, when you see that, that's talking about reciprocal IDs, quotient IDs, and Pythagorean IDs. This one should come to you quickly, I would hope. Cosine, secant. Cosine is the reciprocal of secant. That means, how it's written in your notes, it looks like this. Cosine is 1 over secant. All that means is flip your fraction. So secant at this angle would be 61 over 60. That one's that easy. All right, on 21, you're asked in which quadrant is the terminal side of theta if theta is negative 100. I'm just going to give a quick picture of negative 100 degrees. Okay, negative goes in the clockwise direction. Here's 90, so I'm going to go 10 more. Ta-da, quadrant 3. That's just knowing that negative goes in clockwise direction. Okay, on 22, find the exact values of sine and cosine functions of theta given in the figure. Do Pythagorean theorem to find your missing side, which is your r. So 3 squared plus 3 square root of 3, this whole thing is squared, equals r squared. You have 2 terms in here. The squared has to go to both. So you end up with 9 plus 9 times 3, which is 27. You get 36. Take the square root, and you get 6. It is r, so we're definitely using a positive number. So positive 6. Sine is y over r, cosine is x over r. So y over r, reduce, reduce, reduce. Don't give me this is the final answer. I will take points off. 1/2. Cosine is x over r. Oops, 6. Reduce. So square root of 3 over 2.